Hi everybody, we're going to talk about simplifying radicals today. So when you're simplifying radicals, you want to take note of what prime numbers are. Prime numbers are a number that only have factors of 1 or itself. So all of the numbers that are highlighted in dark green are prime numbers because I can't divide them by anything except 1 and themselves. So 13 is a prime number because I can't multiply any numbers except 1 and 13 to get 13. 59 is a prime number because I can't multiply any numbers except 1 and 59 to get 59. Okay, we've seen this table before. It is all of our perfect squares. And last time I did a video for you, I told you that it would be in your best interest to memorize the perfect squares of 1 through 13. And it's going to help you in this section. We are going to be simplifying radicals. So if you put a radical into a calculator and it is not a perfect square, you would get a decimal as an answer. When we simplify a radical, we're going to be looking for all the perfect squares to take them out, and we're going to leave all of the primes underneath the radical. So we're going to take out all the perfect square numbers and leave all of the primes in there, and we're going to have an answer that doesn't have a decimal. So let me show you how that works. Okay, so I see the number 80. And I'm going to think about my factors of 80 and think, are there any factors of 80 where there is a perfect square? And there is. It's 16. 16 times 5 will give me 80. Okay, so instead of writing this as the square root of 80, I'm going to write it as the square root of 16 times 5. Okay, and we know that 16 is a perfect square. The square root of 16 is 4. So the 4 comes on the outside of the radical. I still have that 5 in there though. 5 is a prime number. There are no factors of 5. There are no perfect squares in 5. So the 5 stays on the inside. 4 radical 5 is my answer. When I simplify the square root or radical 80, 4 radical 5 is my answer. Radical 50. So I want to think about factors of 50 that would have a perfect square in them. So I know that I can do 25, which is a perfect square, times 2. Okay. The square root of 25 is 5, so that comes on the outside. 2 is a prime number, so that stays on the inside. So when I simplify radical 50, 5 radical 2 is my answer. 6 radical 40. So 6, and then instead of 40, I want to write 40 as any perfect square factors. So I know right away that 4 is a perfect square, and I know I can rewrite 40 as 4 times 10. Okay, so the square root of 4 is 2. So that means that 6 times 2 is on the outside, and 10 is on the inside. Now, are there any perfect squares in 10? Well, I know that 10 can be 1 times 10, no perfect squares. 2 times 5, no perfect squares. So 10 is simplified. 6 times 2 can be simplified further to 12. 12 radical 10 is my answer. So 6 radical 40 simplifies to 12 radical 10. Okay. Radical 4 times radical 27. So I'm going to rewrite this whole thing as 4 times 27 all under a radical. I know 4 is a perfect square, so I'm going to do 2. And then 27 I can rewrite as 3 times 9. Okay, well 9 is a perfect square. 9 is a perfect square 3. So I'm going to take the 2 that was already there times 3 square root of 3, because this 9 became a 3 on the outside. So my final answer here, 2 times 3 is 6 radical 3. So radical 4 times radical 27 is 6 radical 3. Division. Okay, so with division, I can take the radicals separately on the numerator and the denominator, or I can take them and simplify them first and then take the square root of the radical. Okay, so here I've got radical 25 over radical 16. Well, those are both perfect squares, 5 over 4. Next one, I've got radical 13 over radical 36. So I'm going to rewrite this as radical 13 over radical 36. 36 is a perfect square, 13 is prime. So the top of this is going to stay as radical 13. The bottom of this is going to be 6. Radical 45 over radical 5. I'm going to rewrite this because I know I can divide 45 by 5. And I'm going to simplify that first, and then I'm going to get radical 9, and the square root of 9 is 3. Pythagorean theorem. A squared plus b squared equals c squared. Okay, well, let's call this A, let's call this B, and remember C is always across from the right angle. So I'm going to have 8 squared plus 10 squared equals c squared. So 64 plus 100 equals c squared. So 164 equals c squared. To find out what just c is, I take the square root of both sides. So now I'm going to simplify that 164. So is there a perfect square that goes into 164? So we think about all of the factors that go in to 164. And I know that 4 goes into 164. So I've got 4 times 41 equals c. Well, 41 is prime, but 4 is not. This becomes 2 radical 41.